Good evening, and thank you for joining in on our talk tonight. If you ask pilots, engineers, historians to name the worst real incident in spaceflight, many pause, choose their words, and return to the same name, Columbia. Not because other losses were small, not because earlier tragedies hurt less, but because this failure began quietly on day one and waited because the harm was both metal and habit. Because 7 people finished a successful science mission and died coming home. Because the lessons reach from foam chemistry to decision-making, from re-entry physics to the psychology of certainty. This is that story, from the first bright column of flame to the long search in pine woods and rain, to the questions that changed how we fly. The shuttle was meant to be our reusable workhorse, an airplane-shaped orbiter, an orange external tank, 2 white solid boosters, a craft that could carry a laboratory, assemble a station, then glide home to a runway. It looked like the future, because for a time it was. Columbia was the elder of the fleet, the pathfinder, the first to prove that improbable machine could fly. On STS-107 she carried 7 professionals, a crew built for science, with Space Hab in the payload bay, 16 days of experiments, fluid physics and combustion, life sciences and Earth observation. A mission that was all work and very good work. Launch morning, January 2003, blue sky, polished call-outs, the ritual music of a practiced team. Boosters lit, the stack rose and rolled, cameras on ground, and tank watched ascent as always. 81 seconds after liftoff, something ordinary and ruinous happened. A piece of spray-on foam insulation from the bipod ramp near the nose attach point broke free. Foam is light. The vehicle was not. At that speed, light becomes a hammer. A pale blur crossed the frame, struck the black leading edge of the left wing, where reinforced carbon-carbon panels guarded the skeleton beneath. No alarm sounded. No jolt reached the cockpit. The plume wrote its bright sentence across the morning. Ascent continued. Foam had shed before. Engineers knew. They logged it, worked to reduce it. Earlier strikes had seemed to leave only scuffs, and a dangerous pattern formed in memory. When an abnormal thing repeats without disaster, it begins to look acceptable. Safety people have a name for that slow drift. Normalization of deviance, not malice, not laziness, just the human comfort that grows around yesterday's luck. On orbit, STS-107 was beautiful and busy. The crew lived on a split schedule, woke to music from home, watched flames behave like pearls in weightlessness, tended crystals that grew straighter than they do on Earth, filmed lessons for classrooms, photographed rivers and deserts and the thin blue line of our air. Voice loops sounded like any good science flight, calm, precise, quietly proud. On the ground, a handful of engineers felt a splinter of worry they couldn't ignore. Debris analysts ran models, plugged in size and angle and speed. Could foam have done more than nick a tile? Could it have cracked or holed the carbon leading edge? They asked for sharper eyes on the orbiter, perhaps a powerful telescope, perhaps Department of Defense assets. A request began to walk through the program and met a familiar reassurance. We've seen foam before, the tiles will be fine. RCC is tough. The mission is not a crew safety issue. The image request thinned out and disappeared into corners of meetings and minutes. No one wanted a bad outcome. People were doing their jobs. But a program is not only good people, it is also how doubt travels, how unease keeps its voice, how ambiguity is treated when the schedule is confident and the data is thin. 16 days passed, experiments ended and were stowed, lockers latched, the cabin made neat for return. Re-entry is a ballet through a furnace. The orbiter turns her belly to the air, traces long S-curves to bleed speed, rides a sheath of ionized gas that glows like a second skin. The RCC leading edges take the fiercest heat. The white tiles glow and live. Hydraulics push elevons and rudder. Computers hold the fall from hypersonic to subsonic with the grace of a glider that remembers it was once a rocket. February 1st, the sky over the western United States was pale and winter cold. Entry interface came, that altitude where air begins to matter. Across California and Nevada, the first hints of wrongness arrived in mission control. Temperature sensors buried in the left wing warmed early. Other numbers drifted. Hydraulic line temps, structural temps, tire pressure indications. Anyone by itself, a shrug. Together, a sentence forming that no one wanted to read. Through a breach in the leading edge, superheated plasma had likely found a path inside, and once heat enters cavities not made to know it, aluminum softens, composite chars, attachments lose their strength. The ship still followed guidance, the crew still heard routine notes from the ground. Columbia, we see tire pressure messages. The commander began to answer. The transmission clipped off mid-word. Over Texas, people on the ground saw a bright contrail feather into multiple strokes, glowing fragments writing diverging arcs across a high morning. There was no single explosion. When structure fails at that speed in that air, it fails completely. The left wing could no longer carry what it had to. The loads found the weak places, and the vehicle came apart. In seconds, 7 lives ended. A mission that had gone well ended in a sky that looked calm from below. In the hours and days after, East Texas and Louisiana became a map of care. Law officers and forest rangers, guard units and NASA teams, locals on ATVs, pastors, teachers, children who had watched the launch fanned out through pasture and pine and bayou. Pieces were found, tagged, carried gently to trucks, then to a reconstruction hangar, where a ship would be laid out again in sections and stories. The remains of the crew were recovered with honor. Roadside memorials bloomed. Volunteers brought coffee. Rain fell and stopped and fell again. Somewhere in that wide search, the OEX recorder turned up, a tough little box that held engineering data not normally telemetered. Its trace of temperatures along the left leading edge gave investigators a final heartbeat from inside the wing. The Columbia Accident Investigation Board assembled, independent bench, charged to name not only the physics but the habits. Tests were built. Foam of the size estimated from ascent images was fired at a spare RCC panel. The impact made a hole. The softness of foam had never mattered, only the kinetic energy of mass at speed. At ascent velocities, the pale stuff was a stone. The report also read the culture, dissent that could be voiced, but found few amplifiers, risk language that drifted toward optimism, a habit of treating as flown anomalies as proof of safety. Schedule pressure that nobody wanted to admit felt heavy. It did not scold. It described how good people inside a successful program can let yesterday's luck become today's standard. Then came the work of changing metal and behavior. The external tank was redesigned, the bipod ramps reshaped or eliminated so large pieces could not form. Spray-on procedures tightened to avoid voids that burst in cryogenic chill. Imaging multiplied ascent, filmed from many angles. On orbit, a new boom rode in the bay, the Orbiter Boom Sensor System, a laser scanner at the end of the arm to inspect tiles and RCC up close. If damage were found, crews had procedures to attempt repair, and flights were planned to visit the International Space Station so a wounded orbiter could shelter while help was launched. The organization tuned its ear. Independent technical authority gained weight. Stop work powers were formalized. Dissent was pressed into the structure. Instead of being left to personality, reviews asked not only for answers, but for evidence chains. Managers practiced treating uncertainty as risk, not as relief. 2.5 years later, Discovery flew returned to flight. Extra cameras watched ascent. The boom scanned the heat shield. Foam still shed in smaller ways. The tank was refined again. A second return mission followed. The shuttle then did the work it had left to do, assembled the station it had promised to assemble, flew until 2011, and retired with respect. Wheels stopped, and a quiet that felt earned. Say the names because the story is technique and steel, but also human. Rick Husband, Willie McCool, Michael Anderson, Kalpana Chawla, David Brown, Laurel Clark, Ilan Ramon. They were not symbols. They were professionals with families and jokes and habits. They ran an excellent mission. They trusted their ship and their team. They died coming home. Their families sat in bleachers and living rooms, then in briefings and memorials. Their colleagues read plots and voice loops until the numbers felt like sand, then walked pastures with GPS units and notebooks, taped labels to scorch fragments with hands that shook, and kept working. Why call Columbia the worst? Not to score sorrow, but to acknowledge scope. A quiet wound on day 1 that waited at the door on day 16. A breach where re-entry heat is fiercest and repair in space was not then possible. A program whose habits, good people's habits, let a serious request soften into a footnote. Lessons that cut from cryogenics to culture, from telemetry to the courage to say, I'm not convinced. That is why the outline of Columbia is still visible, in how we build and argue and decide. What remains after the shock and the redesign are a few sentences that travel beyond aerospace. Never let absence of evidence become evidence of absence. We don't see a problem is different from we looked and did not find one. Treat benign anomalies as gifts. They are auditions for future disasters. Write dissent into the design. Make it easy and safe to say stop. Prove your comfort, not with mood, with data. Honor your luck with rigor. When you are spared, go find out why. Space is not a villain. It is indifferent, and indifference feels like malice when you are fragile. The answer is not bravado. The answer is craft, attention, discipline, and the humility to rebuild both the part and the practice that let the part fail. The shuttle fleet carried that humility into its last years. Later vehicles, government and commercial, carry it now in materials choices, in inspection requirements, in the tone of meetings where one plot line can stop a countdown. There is no ending that pays the bill. There is only a vow. Say their names, keep the story sharp, ask for the picture, even if you fear what it will show. Fix the metal and the habit, and when luck visits, say thank you, then go check why Columbia was a ship. Columbia was also a chain of decisions. We owe both our attention and we owe the crew one promise. That attention will not fade, that in rooms with screens and loops and quiet voices, someone will always be willing to say look again, and someone with the power to say yes will say it. Thank you for listening. Take care of yourself and good night.